Hello guys, welcome back to my YouTube channel. Today we're gonna solve another LeetCode problem called rotate list. So this problem is a median problem, as you can see. Given the head of a linked list, rotate the list to the right by k places. So let's see here. Uh, so 1, 2, 3, 4, 5, right? If the k is 2, let's say we have to rotate twice, right? So in the first rotate, it's gonna be 5, 1, 2, 3, 4. In the second rotate, it's gonna be 4, 5, 1, 2, 3. So we just keep moving forward and in round and round, right? So something like that. Okay, there's a twist here, guys. So let's say k is 4, right? K is 4. So 1 2 2 0. I think you might be able to notice this. Okay, if k is 4, it says 0 1 2 2 0 1, and then 1 2 0, and then as you can see on the third rotate, it's the same as the first. Okay, so we can use modular operator to decrease, and we can just do it one time. We can do it one time and then we'll get the result. Like we can put the 2 in the front and then it will be 201 and it's done. We don't have to run this, we don't have to rotate this all the times. That's the trick. Okay, so let's start with the edge cases. We're gonna check if head equals null or head dot next equals null. If head dot next or k equals null, then we just return the head. Return head, right? So if head is null, that means we don't have any node. If head dot next equals null, that means we only have one node. Okay, that is the current head. And if k equals 0, that means we have to rotate it k times, which is 0. So we don't have to rotate it at all. We just return the head. And then let's start from getting the length of the list. In length, and then length equals 1. And then we have to also get the tail of this list. So list node tail equals head. Let's set the head for now, and we're gonna traverse in the while loop. Okay, so while tail dot next is not equal to 0, it's not equal to 0, we're gonna do tail equals tail dot next, right? And also we're gonna increment the length plus plus, so that we get the length of the list, of the whole list. And that's the catch, the one we're gonna use, the modular operator is here. So we're gonna do k equals k mod length, right? length length, gth length, sorry. So let's say if there are 5, if k is 5, right, and then mod, and if there are 5 elements, then the remainder is 0, right? So that means we don't have to uh, rotate at all. That means we can just return it, right? Or in other sense, if there's like if k is 8, if we're asked to rotate 8 times and the element the list is 5, size of list is 5, then the modular will give us 3. So we just have to we can just rotate it 3 times and then we can just return it. We don't need to rotate all the 8 times. Okay, so we can save the time complexity. Okay, and so gonna check if in that case and k equals 0, that means the remainder is 0, then we just return the head because we don't need to rotate it, right? Otherwise we're gonna get the new tail. There's no new tail equals, let's put it head for now, use 4 int I equals 1. Again, we start from 1 because we are already at the first node. Okay, well, I is less than length minus k I plus plus. Okay, length minus k is important because let's say if length is 5 and then k is 1, I mean when we after we do the mod and everything, if k is 1, then we just gotta traverse 6 times. We will not run, we will not jump out of the list. We will not get into any errors, and we just gotta go 6 times, and that will be the new tail. And then we just find the head, which is next to the tail, which is the head. Okay, so new tail dot next equals no, new tail equals new tail dot next, right? And then now we got the new tail. Since we got the new tail, now we can get the new head. So list node new head equals new tail dot next. Okay, now we get the list new head already. Okay, but the new head and the new tail are connected, and the old head, which is this old head, and the old tail are not connected. So we just gotta finish doing that. So we're gonna do new tail dot next equals no. So this will officially become the tail because there will be no next element, so it's not connected in circle anymore. And then for the tail, okay, tail dot next, remember the tail, which is the actual tail or the old tail of this head. We're just gonna connect this with the head, okay, so that it becomes a single linked list. It's connected. Okay, so head, then we just gotta return, that's it. So return new head. Can connect these two, and then let's try to run this. Oh, where's the binary operator? Give me, oh, not equal to no. Why did I use 0? Run. And sometimes the brain just works itself. You don't know. Sorry, guys. I don't know. Okay, so accepted. Let's try to submit this code. Hopefully we get it right. Okay, 0 millisecond, very fast, very good algorithm. The runtime is order of n, it's linear. Okay, so if you have any questions, or if you have any legal problems you want me to solve next, you can let me know in the comments down below. Make sure to subscribe, hit the bell icon. It gives me a lot of motivation when I see like comments and likes and views, guys. So thank you very much. Have a good day.